This is Jacob's Algebra, Chapter 14, Lesson 2, Part 2. We have worked through the first 3 problems in Set 2. Now we're going to do the last 3 problems in Set 2. So, number 7, there we go. Number 7 is just like number 13 that's assigned for homework. It says 2 rational numbers close to square root 2 are 7/5 and 17/12. So for part A, it says change 7/5 to decimal form. So if you take 7/5 and you put that in your calculator, what you're going to get is 1.4. Part B says, is 7/5 smaller or larger than square root 2? Well, at the beginning of this lesson, it shows you that square root 2 is 1.414, and it goes on for a long time. You have a whole bunch of digits in the answer, and that's at the top of page 674. So there's a whole bunch of digits, but 1.414 is far enough for what we need to do. Okay, so part B asks, is 7/5 smaller or larger than square root 2? Well, 7/5 is 1.4, and that's smaller than 1.414. So that means that 7/5 is smaller than square root 2. Okay, part C says to express 7/5 quantity squared as a rational number. So 7/5 squared is 49 over 25, because 7 squared is 49 and 5 squared is 25. Okay, part D says, asks if 7/5 quantity squared is smaller or larger than square root 2. Than 2. So 49 over 25, when you punch that in a calculator, what you get is 1.96. That is less than 2. So 49 25ths is less than 2. Or actually, I think it asked it as 7/5 squared is less than 2. Okay, so part E. Change 17/12 to decimal form. So 17/12. Punch that into a calculator and you will get 1.416 repeating. Okay, part F says, is 17/12 smaller or larger than square root 2? Well, 1.416 repeating is bigger than 1.414. So that means that 17/12 is greater than square root 2. Okay, part G says express 17/12 quantity squared as a rational number. So 17/12 squared. When we square the 17, we get 289. When we square the 12, we get 144. Part H asks us to compare 17/12 squared to the number 2. So first we have to figure out what 289 over 144 is as a decimal. So punch that into a calculator and you will get 2.00694 with the 4 repeating. So is that bigger or smaller than 2? It's definitely bigger than 2. So 17/12 quantity squared is greater than 2. So okay, so that's all the parts. So what they're wanting you to see here is if a number is less than the square root of another number, then the square of that number is going to be less than the square of the number. 7/5 is less than square root 2, so the square of 7/5 is going to be less than the square of square root 2. 17/12 is greater than square root 2, so the square of 17/12 is also going to be greater than the square root of 2. That's where they were leading you to. If x is less than y, then x squared will be less than y squared. If a is greater than b, then a squared will be greater than b squared. Okay, that's what they're trying to get you to see for this one. So this was number 7. It's just like number 13 that I assigned for homework. So now let's look at number 8. So number 8 says, each of the following decimal numbers might be used as an approximation of square root 35. Find the square of each number, each correct to the nearest thousandth. Okay, so when we're looking at A, part A says 6. When we square that, we get 285. When we square the 12, we get 144. Part B says 7. When we square the 12, we get 144. When we square the 6, we get 144. When we square the 7, we get 144. When we square the 8, we get 144. When we square the 9, we get 144. When we square the 10, we get 144. When we square the 11, we get 144. When we square the 12, we get 144. When we square the 13, we get 144. When we square the 14, we get 144. When we square the 15, we get 144. When we square the 16, we get 144. When we square the 17, we get 144. When we square the 18, we get 144. When we square the 19, we get 144. When we square the 20, we get 144. When we square the 21, we get 144. When we square the 22, we get 144. When we square the 23, we get 144. When we square the 24, we get 144. When we square the 25, That's just 36. But it says to give the answer to the nearest thousandth, so we have to say 36.000. We have to give it to the thousandth place. Okay, part B is 5.9, and we're going to square that. When we square 5.9, we get 34.810 when we round it to, well, actually it's 34.81, and then we add an extra 0 to get to the thousandth place. Part C is 5.92 squared. That is 35.046 to the nearest thousandth. And then we're going to do part D is 5.916 squared. When we square that, we get 34.999. And then part E is 5.9161 squared. And that is 35.000. It is not actually equal to 35. The next digit after this third zero is, you do actually have a non-zero digit over here. But when you round it to the thousandth place, you get all zeros. Okay, so part F says, each number in parts A through E is rational. Explain why. Well, if you look at it, let me see, is it asking for, yeah, 5.9 can be written as 59 tenths. 5.92 can be written as 592 thousandths. I'm sorry, hundredths. 5.916 can be written as 5,916 thousandths. And 5.9161 could be written as 59161 over 10,000. So all of this can be written as fractions. And since they can be written as fractions, it means that they are rational numbers. Okay, part G says use your answers to parts A through E to tell which of the numbers are smaller than square root 35 and which are larger. Okay, so part F was showing that all these could be written as fractions. So I'm just going to write fractions here. Part G is the one where it says use your answers to part A through E to tell which of the numbers are smaller than square root 35 and which are larger. Well, if they're smaller than square root 35, then the square is going to be also smaller than 35. So you can see the ones that are smaller than 35 are 34.10, 34.810, and 34.999. So the ones that are smaller are parts B and D, which are 5.9 and 5.916. The ones that are larger are the rest of them. So 6, 5.92, and 5.9161. Those are the ones that give you a number that is larger than square root 35, because even though this shows only zeros here, the next digit is not a zero. So that one is actually larger. When you punch that in your calculator, you will see. Okay, and then part H asks, is it possible that a decimal number carried out to a larger number of decimal places could be exactly equal to square root 35? The answer here is no. The only way that can happen is if 35 is if 35 is a square number. If it's not a square number, then you can't actually do that, because you can only get the exact value of a square root if you're taking the square root of a square number. So it's not possible because square root 35 is irrational. Okay, so that was problem number 8. It's just like problem number 14 that was assigned for homework. Okay, now let's move on and look at problem number 9. Problem number 9 says solve each of the following equations by using the quadratic formula. Simplify your answers as much as possible, but do not round them. So we're going to leave our answers in fraction form. Okay, so number 9, part A, what we have is 4x squared minus 5x plus 1 equals 0. And first thing I'm going to do is write the quadratic formula over here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So to solve this, we're going to say x is equal to, we need the negative b. Our b is -5. The negative of -5 is +5, plus or minus the square root of b squared. -5 squared is 25, minus 4 times a times c. Our a is 4 and our c is 1, all over 2 times a. That means 2 times 4, which is 8. Okay, so that means we have 5 plus or minus the square root of 25 minus 16 is 9, all over 8. So that is 5 plus or minus 3 over 8. Well, 5 plus 3 is 8, so we have 8 over 8. 5 minus 3 is 2, so we have 2 over 8. And we need to simplify these answers. 8/8 is 1. 2/8 is 1/4. So those are our two possible values for x. Okay, so let's look now at part B. Part B is 4x squared minus 6x plus 1 equals 0. Again, we're going to plug everything into the quadratic formula. Negative b is negative of -6, so that's a +6, plus or minus the square root of b squared, which is 36, minus 4 times a times c, because our a and our c are 4 and 1, all over 2a, which is 8. So we have 6 plus or minus the square root of 36 minus 16 is 20, all over 8. That becomes 6 plus or minus 2 square root 5 over 8. And then we can simplify that to x is equal to 3/4 plus or minus 1/4 of the square root of 5. Or we could leave it all as one fraction and say 3 plus or minus square root 5 all over 4. Either way, those are our two possible values for x. 3 plus square root 5 over 4 or 3 minus square root 5 all over 4. So now let's look at part C. So for number 9, part C, we have 4x squared minus 4x plus 1 equals 0. So our x will be equal to negative b, which is 4, plus or minus the square root of b squared, which is 16, minus 4 times a times c. All of that is over 2a, which is 8. So we have 4 plus or minus the square root of 16 minus 16 is 0, all over 8. Well, the square root of 0 is just 0, so we can just cross that off. So we have 4/8, that is 1/2. So we only have one possible value, and that value is 1/2. Okay, now let's look at part D. We have 4x squared minus 8x plus 1 equals 0. Again, we're going to use our quadratic formula. We have negative b, that's 8, plus or minus the square root of b squared, that's 64, minus 4 times a times c. And then that's all over 2a, which is 8. So that is 8 plus or minus the square root of 64 minus 16 is 48, all over 8. And then we can bring that down here on the next line. We have 8 plus or minus square root of 48 is 4 square root 3 over 8. That simplifies to 2 plus or minus square root 3 all over 2. So we divided everything by 4. Okay, so part E asks a question, which is, what must be true about the discriminant, which is b squared minus 4ac, of a quadratic equation in order for the solutions to the equation to be rational, assuming that a, b, and c are integers? Well, in order for this to be rational, b squared minus 4ac is what's in the square root. In order for that to be rational, this has to be a square number. So if your discriminant is a square number, then you will actually have a rational solution. So that is the last problem. It is just like problem number 15 that was assigned as homework.